Hi, I'm Doug Crawford and this is Stages Cycling. We wanted to take the opportunity to show you around and introduce you to our product, kind of show you some of the benefits, not only about the product, but how we actually manufacture it here in Boulder, Colorado. We're about 300 meters away from Cross Nats. It's taking place here at Valmont Bike Park, so it was a perfect opportunity to show you guys how the product's manufactured and why it's so diverse in terms of the application in cycling. Everything from road to tri to mountain bike to cross, even BMX. So we're going to give you a little bit of a peek behind the scenes in terms of manufacturing the product and show you how we actually progress to what we're doing today and where we think we're going to go in the future in terms of growing and getting more product in the hands of riders around the world. All right, let me show you a little bit about how we arrived at the product that we're selling today. It goes back a number of years when the core team here at Stages moved on from their previous jobs within the fitness and cycling industry. We started Stages as an opportunity really to progress some ideas that we had that just we hadn't seen developed in the industry. Our first opportunity, and you can kind of see a timeline back here of how the power meter developed through the cycles of its application. The first product we developed is actually a steel crank arm that went onto a product that we manufactured for another company. In that particular application, we wanted to measure power, but the bike is sold without power. It needed to easily be added to it. And we decided that the best location to do that from a usability and ease of installation and ease of maintenance and so forth was on the left crank arm. So this is actually almost a 2-pound assembly steel crank that has a power meter on the left crank arm, just as we do today. This has been on the market and being sold for about 3.5 years now. And it basically proved to us that we could build a product that was highly successful in terms of consistently measuring power and provide feedback to the user just like they do outside, but this was an indoor application. You can see that we started to create versions of the technology that ultimately led to what we're selling today. So the first version was kind of what you saw there, was a steel arm with a reed switch and a strain gauge, and all that assembly was basically bolted together so that we could try the technology. And we produced the first unit, which was for the indoor category, and then ultimately we took that technology and built kind of a test mule, not a prototype even, just an early version to say, can this work on an outdoor bike and what do we need to change? That version was ridden. It had a lot of challenges, but it proved that we should keep going with the project. Then we basically moved on and optimized and shrunk the technology down to the point where it was ready to ride as a prototype. And it led finally to what we sell today, which is a very mature product, an extremely small and lightweight product that again goes on power meters across a number of disciplines, from road to mountain bike to really almost any cycling category you can think of across the spectrum. What's really unique about the product, among other things, it's actually less than 20 grams. It normally runs between 15 and 18 grams with a little bit of variation. That includes the battery and everything that you need to ride the device. The other really nice thing is that you just bolt this crank arm on and that's all. There's no magnets, there's no secondary product that goes on the bike that enables it to work. Everything is self-contained within the body. So we have a couple sensors on here that are measuring elements from this device. The strain is measured by strain gauges which are in contact with the metal. They're actually measuring the load or the pedaling force that's going through the crank. We also have strain gauges, or in conjunction with the strain gauges, we have an accelerometer. Accelerometer inside here is measuring the velocity of the crank. So when you have those two components, you can measure and calculate power and send that up to the head unit. The accelerometer is really important because we don't need a magnet to read that. Everything is done within the device. The accelerometer will see pedaling rotation as well as road vibration. And we have algorithms and filters in the software to determine whether or not you're actually pedaling, or it's a road vibration or a big drop off or something that's not really adding to forward propulsion. We basically only calculate that energy that you put into the product to drive forward. And that's the metric that riders need. They need to know how much power they're generating to actually move forward when they're riding. In addition to the strain gauge and the accelerometer, we've got another really neat feature that makes it very user-friendly, and that's a thermistor, basically a digital thermometer that's measuring the temperature of the device all the time. And people wonder, well, why do you really care about what temperature it is? Well, the fact is that all power meters have to be zero reset or zero calibrated. And that basically is just teaching the device what no load is. So in our case, you would basically put the pedal down at 6 o'clock and in your head unit instruct this to zero calibrate itself. And it would measure what no pedaling force is. It's kind of like a digital scale. When you first turn it on, you stand on it and step away and it zeroes out and then you can get on it. That's what strain gauges and all power meters need to do that. What then fluctuates from there is typically the temperature of the device will cause that measurement to drift away from its 0 point, and you need to tell it to kind of go back to that 0 point. Oftentimes with other products, you have to command the device to do that, either by getting in the head unit and instructing it to do that, or backpedal a number of times to zero reset. Ours actually does it automatically while you're riding. So it measures the temperature, and during calibration here, we do an ambient temperature and a very cold point. So that allows us to understand how temperature drift changes the 0 point of the device. And so every couple minutes it corrects itself. So it doesn't matter if you're starting out and it's 40 degrees and you go on a 3-hour ride, and by the time you're done at 75 degrees, it's correcting itself automatically. The rider doesn't need to worry about that. That's a huge benefit to keeping the data accurate. Otherwise, your data is drifting away and you're basically inaccurate as you're riding longer. So that's a killer feature that we have on our product, and it's available, basically the same technology is available on all the models and all the disciplines that we support in riding. Doesn't matter if it's cross or mountain bike or road, they all essentially work the same way. Really what's changing is the underlying crank arm that we're attaching the solution to. Okay, now we're going to take a few moments and kind of show you the manufacturing process, at least in kind of a high detail. Starting from your right to my left, we're going to prep the surface of the power meter. And one of the great things about our design is that we don't actually have to drill in or machine into the metal itself. So we're not changing the way that the crank arm, whether it's a Dura-Ace crank or an XTR crank, we're not changing the way that that crank arm is going to perform or its durability. We're just adding the sensors to that surface. So we prepare the surface, we do a real light media blast to take any anodizing or paint off of that. It goes through a couple of steps to put some graphics on it, get it kind of prepped up. Behind me is where we actually apply the strain gauges with some special adhesive to the surface, and then it's cured for a number of hours to let that to really set up on that surface. It's almost like a chemical weld. Once those materials are cured, it's a permanent bond between the strain gauge and the underlying metal that it's measuring the strain from. After that, it moves on to the cart as you see here and goes through a couple of real detailed steps where we actually communicate with the device using iPads. One of the cool things about our product is that it actually has, we call it bilingual. It's ANT+ protocol, which is very common in our industry when you're talking to head units, but it's also Bluetooth smart. So it can communicate with iPhones and iPads and other devices that are running our application. We actually have a special app that we use here to actually teach the power meter about its firmware, about how to measure strain, and all the programming is done through that interface. Okay, what you see behind me is Mickey actually soldering the strain gauge leads to the computer that's measuring the information coming off that strain gauge. That print circuit board or computer has the other sensors that we use to measure the information necessary to calculate watts. So once those two pieces are joined together, it's going to go down the line and actually have this housing attached permanently to the surface of the crank arm itself. And then once it's totally closed up, it's basically permanently sealed. And then we can move on to the calibration step. I should mention that this is just one of our manufacturing lines. We actually have some others on the other side of the building. Brant is about to calibrate one of our units that's fully manufactured at this point, but it hasn't been calibrated to learn exactly what the loads mean in terms of measuring the torque going through the crank arm. So he's going to go through a number of different steps that will essentially teach the crank arm what zero load and heavy load measure out at using the electronics and the strain gauges. So once he's got it in a vertical position, we're actually going to take a measurement, and effectively that crank arm is being educated or it's measuring what no load is in that vertical position. Then it rotates over to 90 degrees and we prepare to put a very heavy load on what is essentially a pedal spindle sticking out. And that load is going to also give it another parameter, which is a very heavy load on the slope. And by having a 0 point and this 100-pound load, we've got these 2 points of data that create the slope of measuring the load that's going in a pedal when a rider's actually pedaling it. So it takes just a few moments, and as it gets a stable measurement, we actually record that and program it into the board itself. And then the load is removed and the crank arm is taken back to the zero position. And after this step, we actually remove it from the test fixture and put it into the refrigerator and freeze it down to about 0 degrees. And we really want to get it as cold as we can and then take another measurement. And this gives us 2 different points of temperature: the ambient room temperature that we did the first calibration, and then a very cold temperature that gives us the corresponding low temperature, so we can create a new slope from very cold to warm. And that allows us to do the zero calibration automatically when you're out riding. It'll actually take the measurement of the ambient temperature, and if there's been any movement, it can readjust the 0 point automatically. thanks for coming by. We really appreciated the opportunity to show you guys how we manufacture the Stages power meter. Hope everybody did well at Nationals, and we'll see you on the road.